All right, guys, we're just going to do a quick review here of completing the square. So when we're doing completing the square, if you remember, we're looking at this with algebra tiles. So we have our x squared algebra tile, has a length of x, a width of x, and an area of x squared. Then we have the 6x algebra tiles. And we're going to split those up evenly. So we have 3, not 3x, just 3 on this side, because each of these is 1 long, 1 this direction, and x this direction, which means that they're each x. So there's 3x. And then our other 3x right here. Those 3 together are 3. So we have x3 here, x3 here. And then we're trying to figure out how many little ones pieces to fill this in with. You can see that we need 9. One way to think about it is that we have 7. And so how many more do we need to get to 9? But the way I'm going to do this particular one, it's just going to help it be more consistent later on, especially where we don't have an other side of the equal sign to throw the 7 over to, just to make it a little easier since these are just expressions, is I'm going to combine together the x squared and the 6x, and then think of the 7 as this extra thing out to the side. So I'm just going to stick the plus 7 off to the side. So I have like this plus something here, but if I'm going to add something, I also have to subtract that same something. So what I want in here is I want 9 little 1 pieces in here to complete my square. But if I'm going to add these 9 little 1 pieces, I have to subtract 9 pieces so that they're not changing the expression. Plussing 9 and subtracting 9, those two together make up 0, so I didn't change anything. So I'm going to add 9 and subtract 9 from my expression. Then I can look at my outside here of my area model and see that this is x plus 3, x plus 3, x plus 3 squared. All the stuff in the parentheses here, x squared plus 6x plus 9, becomes x plus 3 squared. Then I still have the plus 7 and the minus 9, which together makes minus 2. And that's it. That's my finished completing the square. We use this a lot to get to vertex form. The vertex would be -3, -2. So that's our first example of completing the square. You don't always have to draw out the algebra tiles every time. Instead, you could make an area model. That's x squared. We put 3x here and 3x here. Then pull out the outside stuff. Pull out your dimensions. X plus 3, x plus 3. The 7's still here. We want 9. If we're going to add 9, we have to subtract 9. So you can do this. Draw a line so you can see that. This is with the algebra tile setup. This is just representing the algebra tiles with an area model. They both look very similar. When we get to the next problem, now it has a -5. That's what I'm splitting in half. It's a little harder to do that with algebra tiles. We don't really like to draw halves of algebra tiles. So this one I'm just going to do with the area model, but I'm going to do the same thing we did up on this last one. I don't know if you can see both at the same time. Hopefully we kind of can. I'm going to separate this out so that the x squared and the -5x are together, and then leave the -1 outside of those parentheses. I'm going to add something in here, and then I'm going to subtract the same thing out here to balance my expression. Make it so that I didn't add or change anything to my expression. So I'm going to use my area model to help me with that. X squared. Then I have to cut this in half, right? Up here, cutting 6 in half was easy, 3 and 3. 5 in half's not as easy, but that's okay, especially -5 in half. We're just going to do it. It's a fraction, it's a decimal, we don't care. -5 halves x, -5 halves x. And if you'd rather call that -2.5x, that's completely fine. So our dimensions of our area model, x times x is x squared, x times negative 5 halves, x times negative 5 halves. So this box right here needs to be negative 5 halves times negative 5 halves. I don't have anything there. I want to make sure that I don't forget this minus 1 is still here. So I'm going to figure out what I want. Negative 5 halves times negative 5 halves is positive 25 fourths. So I'm going to add 25 fourths and then subtract 25 fourths. So that's just adding 0. But I did that so that this part in the parentheses, move away from that last example now so we can see what we're doing here. The part in the parentheses is all of this area model here. So I can now rewrite that as x minus 5 halves squared. X minus 5 halves times x minus 5 halves. Then I have the minus 1 and the minus 25 fourths, which together makes minus 29 fourths. And then that's it. I've done my completing the square. All right. Remember, you can always pause and go back if you need to on these videos. That's one nice thing about doing this way, is you can always go back and look at something again if you need to. We're going to try one more. This one's a little bit trickier. These are the kinds you might get to at the very end of your math space assignment. And this is where we have a number in front of the x squared. We haven't done a lot with these yet. So I'm going to do kind of the same thing. I'm going to put these first two things in parentheses. So 3x squared minus 15x. And I'm just going to leave the plus 20 off to the side. But I really don't know how to deal with a number in front of the x squared. So we're going to factor that out. We're going to pull that out of both pieces that are here in the parentheses. So 3x squared minus 5x. Still have the plus 20. And again, I'm going to be figuring out what do I need to add right here to make this work out. And then I'm going to have to also subtract the same thing over here. I almost started drawing my box, but I don't want the box yet, because we have a 3 out here. We need to take that 3 into account. So I'm subtracting 3 times whatever I put here. This 3 is being multiplied by this thing that we don't know what it is yet. So I need to do the same thing on the other side. Now I'm going to create my area model to help me represent this situation. And again, the area model just represents the piece we're completing the square on, the stuff inside the parentheses. So x squared minus 5 halves x minus 5 halves x. It's not always 5 halves. It was on our last example. It is on this one, but because this was negative 5 both times. Whatever this number is, cut that number in half. And just getting the dimensions on the outside of my area model. And then this one, we still have like this 3 out in front. There's not really a great way to put that there. And then we also have the plus 20 off on the other side. There's division between working it out this way and using this area model to help us. Okay, so again, just like on the last one, we need 25 fourths. So if I'm going to add 24 5 fourths, I also have to subtract 3 times 25 fourths, because over here this has got a 3 times this whole area model. So 3 times 25 fourths minus 3 times 24 fourths. Sometimes it's kind of harder to write the 3 and the other stuff over here. Sometimes it's best to just use your area model to find out 25 fourths. Your area model doesn't necessarily have to represent the whole problem, just the parenthesis piece. And then come back here and put the 25 fourths in over here. So now we have 3 times x minus 5 halves squared plus 20 minus 75 fourths, because I have to multiply this by 3. And I'm still going to simplify this last bit right here. So 3 times x minus 5 halves squared plus 5 fourths. 20 minus 75 fourths is 5 fourths. So that would be finishing the completing the square on that one. Again, this one's a little bit harder. You won't probably have to necessarily be able to do this kind of perfect on your own for a mastery check or anything like that. But it's a good example to see, and you may run across some of these as you're working through some problems in your assignments and in your math space and things. The first two are closer to probably what you would see on a mastery check when we get to those kind of things. So good luck, and continue to please let us know if you have any questions or need any help with anything else.